Okay, so now that we are aware of what is a group, now we want to learn about generator. First of all, there is a fact that a group is closed under star. Every group is closed under its operator. Now, what do you mean by closed? It means that after applying the operations, whatever the result I am getting, that belongs to the set G only. So if I am multiplying two integer, and I will get an integer only, right? So if I multiply two real number, so if the set is real number and I multiply two real number, I'll get a real number only. So a group is closed under star, that is for sure, right? Now let's say I'm taking an element alpha. So I am just taking any element, random element from my set G, and now I'm defining some notions here. Okay, so one piece of advice for everyone is that when you are consuming my lectures, so you should focus on what I am saying and where I'm pointing, because there are many things that are written in the slides. So instead of just reading out the slide, you just listen to me, listen to my words, and focus on the pointer where I'm pointing. Okay, so then that will be good for you. So here, let's say I take an element alpha that belongs to my set G, and now I'm defining some notions. Now alpha 0. Now here alpha 0 doesn't mean that I am raising my alpha to the power 0. It only means this is a label. Alpha 0 is a label. Here 0 is a superscript label. I have given superscript labels here, and if the superscript label is 0, then it means that element is identity. Okay, that element is identity of my group. And if my label is 1, if superscript label is 1, then it means that I got this number by applying alpha on my identity element. Okay, so if I have written if it is written that alpha n, then alpha n is the label of that number which I got by applying alpha that I've chosen from a set G, this G, applying this alpha star on another number whose label is n minus 1. Okay, so in general you can say that alpha n we got by multiplying alpha, not multiplying here, by applying alphas. How many alphas we took? By applying n alphas. So here we have n alphas, and that we have applied on identity element. Okay, so alpha n means that we got this element by applying alpha again and again and again. By how many times? We have applied alpha n times on the identity element, and it always doesn't mean that it's multiplication. That's why I'm saying that it is not exponent. This operation can be anything. It can be modulus, it can be division, it can be addition, subtraction. Okay, so if it is addition, that I can say that I am applying alpha plus alpha plus alpha plus alpha. So if it is a plus, if this operator is plus, then I can say that alpha 2 or alpha 4 I got by alpha plus alpha plus alpha plus alpha 4 times alpha plus 0. So I am applying this alpha 4 times on the identity element. So you get it, right? So I am starting with identity element. I am applying alpha on it, then I am get alpha 1. Then I again apply alpha on it with operator star, then I get alpha 2, so on. So I keep on getting new and new number, and I am incrementing the label, superscript label. So you got the notion, right? So here in general I can say that alpha n is the outcome of applying star between. So here it is alpha n minus 1, not alpha. So by applying alpha n minus 1, by star operation alpha n minus 1 and alpha, so I'll get alpha n. So just a correction here, it is alpha n minus 1. Okay, so in case of multiplication it will act as a exponent. Okay, it will like be like that I am raising to some power n, but in general just think it like a label, because in case of addition subtraction we don't raise to power. Okay, so you are clear with what is closed, you are clear with that I take a random number, I took a number alpha from G, and I'm applying it on identity. By how many times I'm applying, I'm getting in that many times label of that alpha. Now if I take any element B from G, now any element, okay, so here I just took one element alpha, so from set I took any alpha. Now I am taking any element from G, so it should be true for every element of G except this alpha, or actually for all elements. It can be alpha or it can be anything. So if I take any element from G, and if there exists any power, any number I, that if I apply that many times on, if I able to find if I able to find a label I, so what does it mean? What does it mean that if I able to find alpha I, that means I am applying alpha I times on identity. If there is a number exists which is equal to B, so for every element in my set G, I am able to find I, which is a label of alpha, then that means that alpha is the generator of my group. So you see here, alpha is able to generate every element of G, if it is possible. It is not always true, right? So if alpha is kind of a number which can generate every element of my G, then that alpha is called generator of my group, right? Let's say I have a set of A, B, C, D, E, and I took E. Now by E, first of all, let's say you may confuse it with identity element, so let's take it as F, and identity element is E. So E is an identity element. Now let's say F is an element, or F any element from this group, and I am applying F on identity, I'll get F1. Then I'm again applying on F on this number, I'll get F2. Then I'm again applying, then I got F3. And if this F2 is equal to A, and this F3 is equal to B, and F4 is equal to C, and F5 is equal to D, what does it mean? That using F, I am able to generate A, B, C, D, and F also. F raised to power 1 is F label 1 is F only. So by using just F only, I am able to generate every other element of my group, or my set of my group. In that case, this F element will be called a generator of my group. Okay, and if I able to find, now it is not true that every group has a generator. Every group, it is also possible that some group does not have any such element which can generate every other element. So if it is true that for any group I am able to find a number alpha which is able to generate every other element of my set, that alpha is called generator, and such set or such group is called cyclic group. Okay, the number which is able to generate every other element of my group G, that number is called generator, and such group is called cyclic group. Alright, so now you know what is generator. So this was all about generator.